Hello and welcome back. We'll be discussing module 3, a few more concepts on the data warehousing. So let me bring my screen. So today I'll be covering what is the difference between data lake and data warehouse, what are the data marts, and what are the steps to reach to the dimension modeling, and what is the star versus snowflake schema. So in last module, we introduced that we'll be using a case study of an e-commerce fashion brand who is into online selling of clothes. So why it is important to understand? Because gradually once we are building the data warehouse for this fashion brand, we should be aware of these concepts. We briefly talked what is ETL, ELT. Now here, let's see with this diagram. What is data warehouse? We already know now, and ETL process is closely integrated and associated with bringing the data into the data warehouse. So then the concept of data lake came into the picture. So to understand this, why data lake came into the picture, first this is in a standard way. Data warehouse is primarily meant for getting or storing the data into the structured format. And we say it is more of a relational data that is stored in rows and columns, and then it is consumed for the reporting. While as we see, like 3 V's in the world of data that we call velocity, variety, and diversity of data. So with that increasing data become different kind of data came into the picture. IoT, the data is into the log form, and then there are data like YouTube videos or audio files, and also the concept of ELT came into the picture, where we are saying that we don't transform it before loading, but we load the data into the raw form. And the need is because processing all this data, which is increasing with high velocity, is not possible. That's why the data lake comes into the picture, where the ELT also came into the advent, where we load it into the data lake. In data lake, how it is different from data warehouse. While data warehouse store the data into the structure format, data lake is more of you bring it in any of the structure. It could be video form, it could be semi-structured form. All those data can be dumped into the data lake. And the need for storing the data and doing the analytics emerged, and that's why these concepts also emerged, that we should have the data lake into the picture, and then data warehouse become the another layer on top of it. Few of the architectures show that we can consume directly from the data lake, and the reporting part can consume directly from the data lake. So now it's not mandatory that data warehouse becomes the end point for the consumption of the reporting. Few of the analytics or advanced ML, it can be done on the unstructured data also from the data lake. So that's the difference between two things, data warehouse and data lake, also the process of ETL versus ELT. Now, what is data mart? So far we have been saying that whatever ETL or ELT comes, data warehouse becomes one central point or the consolidated area where all the data is coming, and then that becomes the consumption for the reporting or the ad hoc queries. While data mart is something we can consider it as a subset of the data warehouse. Why there is a need of the data mart? In scenarios where we really want to separate the data from the functional standpoint. So we have got all the data, but still we want that sales data should remain separate. Now, when I say the sales data should remain separate, it's not like that. It will still be part of the data warehouse, but some aggregated values would be stored into the separate data mart that would be accessible to the sales function itself, and even the reporting would be directly done from the sales. Similarly for the marketing, similarly for the HR. So primarily why organizations try to create data mart is just to have the efficient governance, so that definitely one department will not have access to the another department. So just to maintain those separation in the departments, typically data marts are created, and also and it's not like the data warehouse isn't, as we said, that it's a non-volatile thing. So all the history is always stored in data warehouse. Each record by record, everything is stored in data warehouse. Unlike in data mart, it's not mandatory that we are storing all the records. We can take a chunk of that data set, maybe 15 years of data is there in all, and data warehouse will have those 15 years of data, while the data mart can store only the 3 years of data. That is all aggregated and required for the consumption. It's all vary depending on the business use case, but that's the concept of the data mart. Now comes the main picture. How do we start our journey to create the dimension models? So very first step is we should understand the business. So as we said that we have already identified our use case. So whenever in your project scenarios you try to create the dimension models, first you should understand what is this business all about. So in our case, it is an e-commerce business, sales, fashion, clothing, online. And then we should ask, and as a business, as a data warehouse consultant, we should ask the business what is important for them. Then second comes, as we discussed, what measurements are important to analyze. So when that way we'll be able to drive the facts at the later stage. And the third point, understanding the business, these are the key things that you should ask any of your customers if you are consulting for the data warehouse or dimension modeling. Third question you should ask is, how does the current operational data set look? So current operational data set means, as I said, that in this particular use case that we are looking for the Glamrek brand. So current operational data will store all the product information, their sales information. So whatever data is available in the current operational data set, those only things we can bring into the data warehouse. It should not, like business should be expecting something else out of the box that is not available in the operational data set, right? Then the second steps comes to identify the granularity. So what do we mean by granularity is the level of details that should be available that should meet the end results or the analytics answers on the data. That is the granularity. For example, suppose this is one of the data sets. Just focus on this customer ID, order ID, and total sales amount. If we try to store our data in this tabular format, this might solve one purpose, that we are getting the total sales amount on each day for each customer ID. But if we try to answer whether I have the details on the products what were sold on that particular date to that particular customer, so this is not the right data table design that I would be looking for. So what I want to have a one more down granular level to get those product IDs here. Now you see this total amount sales that is counting for 1500. In this further drill down table, that is 101 customer ID has got two of the product IDs. So 11 and 12, that is accumulating to the total sales of 1500. Now this makes sense that I should have one more granular level of data. Now while I'm designing the tables for my data warehouse, I should understand what all details at what level I should capture. Now this table again is not up to the granular level, because there could be possibility that one product ID has been sold by multiple counts. Say for example, product ID is 11, but we don't know how many products were sold on this date. There are chances that 11 product was purchased twice. So two count of the product. So we need to have a count as well in this to reach to that granularity. So we'll design our tables in that manner. It is just an example to show you that we should not jump in creating an aggregated tables in data warehouse. We should have the data at each granular level so that we can address the analytics question as much as possible. So that becomes the second step. Once we understand the business, we identify the granularity, what is required. Third comes the identifications of dimensions. So dimensions and facts we have already discussed in the previous session. Dimensions will help us to understand who, what, when, where, and how. All these kind of questions will be addressed through the dimensions. Like we check these questionnaires as well. What is the average expense on marketing by campaign, by product, by day? Another question could be, what is the total sales by product, by day? So now with this, these are just two of the questions that anyone would want to understand. There would be unknowns as well, and we want our data warehouse to be created that it can address a lot many questions from the business standpoint. So that way, from these questions, we get to know that but the product would be one of our dimension table. That's why we need a product dimensions. And then since we want to understand the expense by campaign, campaign will become our another dimension and dimension table that will store the details of the campaign. And again, by day is something which we are trying to address. So date will become our another dimension. So that way, that becomes the process. After that, we need to identify the facts. So facts would be the measurements that business would want to analyze on. So that's the four-step process. First, we understand the business, we define the granularity, we identify the dimensions, and then we identify the facts. So with this, now comes the another concept of schema designing. So there are two primary design principles, or I would say the structures. One is the star schema, another one is the snowflake schema. So let me give you this glimpse so that you'll be better able to relate it. So we are doing it for a fashion brand, as I said, Glamrek.com, which is an online store selling the t-shirts here. Now you see, this is one category. You consider that in the men's category, there is another subcategory that is top wear. Under that, there is a product that is oversized t-shirt. So we'll see how this data would be structured in the data warehouse, both from the star schema and the snowflake schema. So I'm giving the practical example so that you will be able to relate it properly. Now, coming back to this, so what is a star schema? So star schema is something when we try to design the dimensions that store the data in one table itself. So whatever dimensions are there that we saw, like the category was men's and there is a subcategory top wear, and then comes the product that is oversized t-shirts. So all of this is stored in a single table. Likewise, there would be multiple columns that can be added, and we will further have the single table that can be associated or would be joined later with the different fact tables. So what is in this design, what are the pros? It enables us to do a faster query performance because we don't need to do the joins on the multiple tables. I will show you in the snowflake schema. The whole idea is we break all the tables and then don't have the redundant data. Now you see in this schema design, there are repeated columns, repeated names in the data in the columns. So oversized t-shirts, imagine like once we have all the inventory, there could be multiple oversized t-shirts like the polo t-shirts for men, women, kids, all those things would be repeated. That makes the storage cost too high because we are storing the redundant data. So this is one of the cons of having the schema design as a star. Now, the same data if we have to store in the snowflake schema, so it would be more of the distributed into the multiple tables, where just to avoid the redundancy or the repetition of the data, we keep the category as another dimension where category name is there, man and women, and similarly the subcategory become another dimension where we list all the subcategory name. Imagine since the inventory is huge, a single table in the star schema, it would have millions of records to have all the inventory of the products that are there. And then this becomes the product ID, product name, and subcategory ID. So these are still linked by the primary key and the foreign keys, but the redundancy is reduced. That's the concept of snowflake schema. So here what it will become, whenever we are trying to identify some of the results or answers from these tables, we would need to perform more of the joins. So joins are typically a very costly kind of, I would say, in data warehouse. So we need to avoid those kind of things. But there are scenarios where we may go to the snowflake schema design as well. Just summarize here difference between conceptually the star schema and snowflake schema. So star schema is more of a denormalized, as we saw, single table will have all the columns, and snowflake is more of the normalized, multiple tables are there. From the query performance wise, a star schema is faster because we don't need to join so many tables. Snowflake schema it is slower because we need to join. Redundancy, as I shown you in the column, there is a repeated data. In star schema it is higher, and in snowflake schema it is comparatively lower. And then from the ease of maintenance, it is easier for reporting, Star Schema. And from Snowflake Schema, it is harder but efficient storage. So business uses both of these schema designs for different purpose. We will see from our use case. Now we will enter into, with this conceptual understanding, we are good to enter into creating our own facts and dimension table for Glamrek. There we will discuss on few of the fundas, when to use Snowflake and when to use a Star Schema. And now in a modern data warehousing, there is a concept of storing the structured data as well. That is, I will talk on that in the later part, but we can handle the Snowflake schema design and the Star schema itself just by defining those data types. So we'll discuss, as I mentioned, like in module 2, that we will be working primarily on the GCP as a cloud to implement all this. There we'll be discussing more on these fundamentals. Thank you.